Hello, everyone. Welcome to Unit 3, Lesson 5. We're going to be talking about the power rule today in our lesson video. So this was a topic we went over yesterday in our Desmos lesson. We talked about two different variations of the rule. So we're gonna talk about how to expand and simplify expressions using the power rule, and then we're also going to talk about how to expand and simplify expressions using the power of a product rule. All right, and then we're going to compare and contrast different exponent rules because it's really easy to get some of these rules confused, especially when you don't have a lot of experience with them. All right, so it's a good thing to see them side by side and see different variations of the problem so that we know how to handle those when we get there. All right, so let's take a look at our first expression here. This is a good opportunity to kind of look at what the power rule does. All right, so you can see here inside the parentheses, we have 2 raised to the third power, and then the entire parenthesis is being raised to the second power. So let's go inside the parenthesis first. We have 2 to the third power, which essentially means 2 times 2 times 2, right? That's inside the parenthesis, and then the parenthesis itself is being squared, right? So that means we need everything inside the parenthesis to be multiplied by itself, all right? So since we have a 2, we want it multiplied by itself twice, right? So we need a 2 times 2 times 2 times another 2 times 2 times 2. And there we go, right? So this would be fully expanded right here. We expanded inside the parenthesis first, then we applied the exponent to expand the parenthesis itself fully. All right, so now if I look at how many 2's I have 1, 2, 3, 4, 5, 6. So if I wanted to simplify this thing, I can put them all back together with a single exponent and say this is 2 to the 6th power. Okay. And we can do the same thing now. Notice this one, the base here is x, all right? So before we were doing a base of 2, so we're switching from a number to a variable, but it works the same exact way, right? We expand what's inside the parenthesis first. We would have x times x times x, and then the parenthesis would be squared. So we're going to have x times x times x times another x, times another x times x times x. There we go. So again, if I count them up, we get 1, 2, 3, 4, 5, 6. So we get x to the 6th power. All right. Now taking a look at this last one, when we have expressions like this, a lot of times students will get confused with a power to a power rule versus what we like to call the product rule here. And notice these are two things being multiplied that have the same base. So if I were to expand this, we would get x times x times x, and then the second part here would simply be x times x. Now, if I count up the x's here, we get 1, 2, 3, 4, 5. So this would simplify to x to the 5th. So in this scenario, when we have a power raised to a power, and I'm looking at what's happening with the exponents, right? Because it asks down here, what pattern are we noticing? Well, in these first two, we did 3 times 2, and we got 6, right? So it's like we multiplied the exponents when we did the expanding process, okay? And the same thing here, if I did 3 times 2, we got 6. But here we're not raising a power to a power, we're multiplying two things with the same base. So it's a little bit different than what we did before. So this is the first rule that we learned. This is called the product rule, and we actually added the 3 and the 2, and we got a 5, okay? So we're going to make sure we keep those patterns straight, and we're going to use them to simplify expressions that might have bigger exponents, because those shortcuts really help out when we get the big exponents. All right, so this is a power to a power. All right, so we have x to the 12th raised to a power of 3. So something raised to a power, then raised to another power. So this is a good opportunity to multiply those exponents like we did up here. All right, so if I do 12 times 3, well, that's 36. So I know this is going to end up being x to the 36th power. And that's a lot easier than writing out 36 multiplications of x. Okay, so let's try this one here. This is 2 to the 15th raised to the 10th power. Right, so I have 2 to the 15th raised to another power of 10. So I can multiply these exponents here, and I can say, well, 15 times 10 is 150. So this would be 2 to the 150th power. Do not try and put that into your calculator. Okay, all we're doing is simplifying here. All right, so make sure you pay attention to the wording of the directions. We're not evaluating. All right, so if you put this into your calculator will probably blow up because this number is so big. All right, so let's go to this one, c to the 14th times c to the 5th, right? So this is a situation where we are multiplying two things with the same base. This is not a power to a power rule. All right, so in this case, if I were to expand this, I'd have 14 c's, and then I would have another 5 c's. So that's going to be a grand total of 19 multiplications of c. So this would be c to the 19th power. All right. So again, make sure you recognize the difference between a problem that looks like this and a problem that looks like this. All right, two different things that you do with the exponents there. All right, so let's see if we can kick it up a notch. We're going to get a little bit more complicated. This is what we call the expanded power rule, or the power of a product rule. All right, and the reason they call it that is because inside the parentheses we have two things that are being multiplied. We have a 2, we have an x. Both of those things are being multiplied, and then the product of whatever that is being squared. All right, so the parentheses being squared, so we're thinking, well, we need 2 of those parentheses, just like we saw in the previous problem. So we need 2x times 2x. Okay, so that is 2x quantity squared. All right, now because this is multiplication, I can actually rewrite this in any order that I like. So I could put the 2's right next to each other, and then the x's right next to each other, just like that, and then multiply the 2's. That would give me a 4. And then if I put the x's back together using an exponent, that would be 4x squared. All right. So that is a very simple expansion of a power of a product. Okay. Now this one, notice there are no parentheses on the 2x. Now in this case, the only thing the exponent is being applied to is the x. The 2 is not being squared. Okay, so when I expand, I only need 1 2, but since the x is being squared, we need 2 multiplications of x. Okay. So this will just be 2 times x in its expanded form, and if I put it back together, we end up back where we started. There really is nothing that is changing from the original expression to the new one. Okay, so notice the difference in the end there when we put the parentheses around the product and when we don't. Right? So let's take a look at a more complicated one here. So again, look at the outside exponent here. We're raising something to the third. The thing that's being raised to the third is this entire expression inside of the parentheses. So the entire parentheses is being raised to the third. So we're going to have 3x squared times 3x squared times 3x squared. Okay, and then notice these x squared, so we could say 3 times x times x times 3 times x times x times 3 times x times x. And then we can write this in any order that we want. Since it's all multiplication, we could do 3 times 3 times 3 times x times x times x times x times x times x. All right. And then if this would be fully expanded here on this line, or even in the second line, I would take either one of those as fully expanded. This first one, not fully expanded because we still have exponents present in the expression. So you expanded it a little bit here in the first line, but not completely. All right. So now we're going to put this back together to simplify it. The 3 times 3 times 3, we want to just go ahead and evaluate that. So 3 times 3 is 9, 9 times 3 is 27. So we'll get a 27 in our final answer, and then we just count up the x's. So 1, 2, 3, 4, 5, 6. This will be x to the 6th. Okay. So again, just trying to recognize patterns here. Notice we got an x to the 6th, and we have a 3 and a 2 here. So we did multiply the exponents to get that 6, but we also made sure we applied the 3 to the 3rd power to get that 27. So it's almost like we're distributing the exponent to each thing inside of the parentheses. All right, let's take a look at this next one. All right, this is a quotient. A quotient's a fancy word for fraction. Okay, and if I expand this thing, right, we need x over 5 twice. Right, so I'm going to write this as x over 5 times x over 5. All right. pay attention to what happens here. X times x is x squared. And then 5 times 5 is 25. So this would be its simplified form. It really doesn't look like anything special happened, but we applied that exponent to the top, right? So x squared, and then we also apply the exponent to the bottom of the quotient. So we do 5 squared and we get 25. All right, keep going. We're going to try some challenging ones here, right? Get a little bit more complicated. All right, so let's see what we got here. So we got 2x to the 7th over 3, and it wants us to simplify. I'm not sure there's a whole lot to do to simplify here, but if I were to expand it, we would get 2 times x 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 over 3. And I think the only thing that we would be able to do to simplify is maybe find something to cancel out, but there is literally nothing that cancels out here. So this expression is not going to change. It's just going to be 2x to the 7th power over 3. All right, it'll just stay like that. All right, let's give this one a try. So we have the parenthesis being raised to the 4th power. That's a very big exponent. I'm not going to try and expand this one. All right, instead what I'm going to do is I'm going to use that distribution pattern that I saw in the one problem that we did on the previous page, and I'm going to apply the 4th power to the -5. So I'm thinking -5 times -5 times -5 times -5, right? So I might open up my calculator to help me with that. Let's see what we get. We're going to do, let me clear this out. We've got -5 times -5 times -5 times -5. There we go. So that's 625. So I'm going to go ahead and write that down. And then we have v to the 17th raised to the 4. So we're going to multiply those two exponents. So 17 times 4. And that is 68. So we're going to have 625v to the 68th power, right? And notice how there is no column here for expand. It's because I want you to use these patterns and use these rules that we are figuring out as we go along here instead. So that was a lot easier than writing out 68 v's. Even writing out the 4 -5s here was kind of annoying. The patterns help out. All right, so let's take a look at this one. There's a lot of pieces here, but I think we can handle this one. So I'd like to take a look at the numbers, right? So we have a 4 and an 8. Now remember, everything here is being multiplied. So I could do 4 times 8, and I know that's 32. All right, then I look at my a values here. Let me zoom in a little bit so we can make it easier to highlight. I'm going to start with the a's, right? So we have an a to the 3rd and an a squared. So I'm multiplying a to the 3rd times a squared. Well, that's a situation where I'm going to add the exponents, right? So that's going to be a to the 5th. All right, and then I'm going to go to the b's, right? So I have a b to the 7th and a b to the 8th, right? So that would be 7 b's and then 8 more b's. So that's going to be 15 b's, right? So again, adding the exponents. So we're going to have b to the 15th power. And then the last one here, the c's. I have 3 here and 3 here, so that's going to be a grand total of 6 c's. So we'll have c to the 6th power. And there we go. So that was pretty easy, actually, using the exponent rules. I didn't expand a single thing. I just multiplied the numbers and then took care of the variables one by one. All right. Let's look at this last one here. This one looks pretty complicated, but I think we can handle it. So I'm going to start with this. I'm going to go to the most inner parenthesis here, and I'm going to start with the 7. I'm going to apply the 7 to the 2 and to the x. And we'll write this out one thing at a time here. So we got x to the 5th, and this is in the top, times 2 to the 7th. Let me grab my calculator to do that, right? So 2 to the 7th power is 128. And then x to the 7th. Right, that's all being multiplied there, all over x to the 3rd. All right. Well, again, just staying in the top here, notice that I have, I can rewrite this in whatever order I want. So I can say x to the 5th times x to the 7th times 128 over x to the 3rd. Well, I see an opportunity here, right? So if I were to combine these, I would have 5x's and then 7x's. So that's actually a grand total of 12 of them, right? So I could say x to the 12th times 128 over x to the 3rd, all right? And then we have to kind of think back to lesson 2. Notice that I have these two x's right here. They are being divided. So I would have 12 x's in the top and 3 in the bottom, and then we would cancel 3 of them out. So all that would be left is 9, right? So we can subtract the exponents here since there is division in between them, right? So 12 minus 3 is 9. So this is going to be x to the 9th power times 128. Or we can just say 128x to the 9th power. And this would be as good as it gets. Okay, so that was really good opportunity. We did a power rule or a power of a product rule. We did the product rule, and then we did a quotient rule, and we got our final simplified version. All right, some of those are going to be challenging, guys. It's not a horrible thing to be challenged every once in a while and kind of push yourself to do some more of the complicated problems. So, give them a try, do your best, and if you get stuck or you have questions, make sure you ask in the Zoom chat. All right, guys, that's it for today. Have a great day, and we'll see you tomorrow.